Okay, series. These problems, a lot of you are just making this more difficult than it needs to be. This may look a little complicated, but if you notice, you're only going from k equals 0 to 3. So really, in this type of problem, they're just expecting you to plug in 0, 1, 2, 3, and just add them all. So first thing I would plug in is 0, so 1 over 0 squared plus 1, plus, next number would be 1, 1 over 1 squared plus 1, plus 1 over 2 squared plus 1, plus 1 over 3 squared plus 1. Okay, so nothing too fancy here. 1 over 0 plus 1 is just 1, plus 1 squared plus 1 is 1 over 2, plus 1 over 5, plus 1 over 10. So probably not a calculator. Notice how you have 1 plus these numbers, means it definitely is bigger than 1, bigger than this. Does not exist. If I look at these numbers, you definitely can add these up, so that's not it. By elimination, it's most likely 9/5, but let's double check. I'm going to rewrite these all in all over 10, so this would become 10 over 10. This would become 5 over 10. This would become 2 over 10. It stays 1 over 10. Now that I have those, add up the numerators. 10, 15, 17, 18. 18 over 10. Reduce, divide by 2. You're going to get 9 over 5. And that is the answer. This one, again, you're just going from 1 to 4. So you might see a pattern here. If I plug in 1, you're going to get 1 minus 1 squared plus 1 cubed. 1 minus 1 is 0. That goes away. Plus, and then I plug in 2 minus 1 squared plus 2 plus 1 cubed. Then plug in 3. 3 minus 1 squared plus 3 minus plus 1 cubed. And then the last one would be 4 minus 1 squared plus 4 plus 1 cubed. Okay, so 0 squared, 2 cubed, 1 squared, 3 cubed, 2 squared, 4 cubed, 3 squared, 5 cubed. Okay, and then again, one more step. This goes away completely. This becomes 8. This is just 1. 27. 4. 4 times 4 is 16. Times 4 is 64. 9. 5 cubed. 5 times 5 is 25. Times 5 is 125. Alright, so I can start to add those up. 125 plus 9 plus 64 plus 4, 27, 1, 8, and 0. Add these up. Okay. Let's see. 5, 14, 18, 22, 29, 30, 38. I can already see that it looks like it might be that one since it ends in 8. So 38, carry the 3, 3, 5, 11, 13. Carry the 1, 238 is my answer. Moving on to the next one. This is an obvious geometric series where r equals 1/10. You know it's geometric when you have some sort of ratio raised to some power, or even a ratio raised to a power plus or minus 1 or something like that. So anyways, this is going to infinity, so I'm going to be using the infinite sum for geometric, which looks like this: a1 divided by 1 minus r. a1 being the very first term I get when I plug in 1. Plug in 1, you get 1/10 to the first over 1 minus 1/10. I'll keep 1/10 on the top. 1 minus 1/10 leaves me with 9/10. Then taking the numerator, moving that up, or taking the denominator, moving that up to 10 over 9. Before I multiply, I can cancel the 10, so I'm left with 1 over 9. And that's the answer. Last problem, also very much geometric series. The way I'm going to do this, though, is I'm going to factor out the 6 so that I have this. I equals 1 to infinity. Now what you might notice is that that's the exact same problem, at least this part, is the exact same problem as before. 1/10 to the k, 1 to infinity. 1/10 to the I, 1 to infinity. Same thing, since my answer back here was 1/9. I'm going to replace this entire thing with 1/9, just this red part. Replace it with 1 over 9. So then what you would end up getting is 6 times 1 over 9. That would reduce to 2/3.